Space habitation is no longer science fiction. It's becoming a strategic reality. As India accelerates its journey beyond Earth, a new generation of startups is redefining how humans will live and work in orbit. Akashalabdhi, an IISc-incubated space tech company, is preparing to launch AntarikshHAB, India's first scaled-down inflatable space habitat. To discuss this landmark mission, its technological breakthrough, and India's role in the future space economy, I am ETV Bharat senior journalist Dr. Anubha Jain. Today, in conversation with Siddharth Jaina, CEO of Akashalabdhi Space. Welcome to our channel, Siddharth.
Thank you, ma'am. Happy to be here.
So, first, like to know what insight convinced you that space habitation, not launch vehicles or satellites, was where India needed to lead.
Ma'am, so space habitation, when we speak of, is something which is not new. I think we have seen Apollo missions coming through, and we are now seeing Artemis missions coming through. So humans have always been intrigued with, trying to live outside Earth, be it in orbit or be it on lunar surface or Martian surface. When it comes to specific to India, we have been the nation that has done the most with the least. So our launches, we've been doing, ISRO has been doing the launches, PSLV, GSLV since past 70, 80 years now. Our research when it comes to electronics and propulsion is at the peak. This also includes the structures. We have a good base of IITs, institutions like IISc, IIT Roorkee, IIT Delhi, who have already done a lot of R&D when it comes to space applications and space technology. But I always felt that where is the point that we are missing when it comes to Indians starting to look at human space flight, or Indians starting to push humans to the orbit or to the surface. And when I did an in-depth research over this, it was not the technology that was the problem. It was the constraints that we face as a geography that came out to be the problem. You know, and that is where I realized that it is you know, the weight of these components, the weight of, for example, the ISS. And these are very huge structures, and the launch cost itself becomes so high when you launch a 200, 300 ton structure, where the launch cost previously were somewhere around 30,000 USD per kg. Now it has dropped down to 12,000 USD per kg in today's time. But still, if you see 12,000 USD per kg, you are launching a 300-ton structure. You are approximately giving away around 120 to 150 CR just for the launch. Uh,
Yeah.
this is a big constraint for an economy like India, and we have, as I told you, we have been known to do more with less, and that is where the concept of inflatable space structures actually started. It's not a new thing that we've been doing or Akashalabdhi is doing. Inflatable space structures have been there around since 1970s and 1985 timeline. The only gap that was there with inflatables is there was the materials that would support the structures were not there. When I say materials, materials that provide you radiation shielding for an inflatable were not there. Materials that would prevent space debris or macrometeoroid impacts for a soft good or a soft material like inflatable were not there. So that
Okay.
is where my research started, and the team started working on the material part first and the structure part second. And that's how it came to me that yes, once we solve the material problem and we solve the structure problem, then there is the limitation that India is facing to have push humans to the orbit or to the surface can be solved pretty easily.
So, how does Akashabdi change India's role in the global space ecosystem if I talk about from a launch service provider to a space infrastructure leader? So,
Ma'am,
how it will change?
yeah, so basically, we are not a launch company. Our job is to create structures in space where you can carry out in-space operations, human spaceflight missions. Consider us to be like a inflatable ISS or inflatable space station. But
Okay.
with that, we also provide our re-entry services. So we have our own inflatable re-entry module. We have our own heat shield. We have our own qualified MMOD layer. So what this gives us a edge is. Uh, we can create structures all the way up from 70 cubic meters, which is going to be our first launch, in fact, this July 2026, to all the way up to 500 cubic meters. Now, if you imagine a 500 cubic meter structure, imagine it to be like half the size of a football stadium. Now, imagine where a ISS where you can only put 5 or 6 humans at a time, and imagine a 500 cubic meter structure where from you can have 30 to 35 humans working together in different projects in a single infra. So that's what gives us the edge, and that's what gives India the edge with Akashalabdhi.
True,
Uh,
well said. Yeah.
yes.
So, if I talk about government perspective, so what regulatory or policy gaps exist today for private space habitats, and what support does India need, to accelerate commercialization?
Right, ma'am. So I think human spaceflight standards and regulations are pretty clear when it comes to the western part of the world. India is still maturing in this technology. We have just carried out our first human spaceflight mission where with Captain Shukla went to the ISS. So it's still a maturing industry when it comes to India. So it would take the effort more from the industry, I would say, rather from the government, where companies like Akashalabdhi and many more companies, I hope, come out in future who work on human space flight, where they carry out multiple missions, validate multiple technologies. That builds a good standard or good qualification protocols, and which government can rely on to make regulations and ensure that all human space flight missions are something that India pioneers in future. When it comes to human space flight, again, the human part is very important. The safety of the human, uh, you know, uh, going there, staying, and coming back is of utmost important. There is nothing more prior than the human life there, and that requires a lot of combined effort. So companies like startups like Akashalabdhi, we can only solve part of the problem. Like we are solving for the structure or giving an infra in the orbit. But there is also another part of the problem when it comes to the human physiology, where the astronauts have to be of right mind physically and mentally, and their health has to be monitored constantly uh, to see their safety in space. And that part, I think it is something that government has to take the lead. Because
Right.
again, astronaut programs cannot be done privately. It has to be something that has to be validated by the government
Collaborated with.
itself. Yes,
Yeah,
ma'am.
true, true.
So if
So,
if the government solves the human physiology part, and we solve the structure part and the space infra part, I think that would be a good value addition to the entire space economy when it comes to globally.
right, right. In continuation to this, I like to know how does Akashlabdhi think about sustainability and orbital debris and responsible expansion?
Yes, ma'am. So, sustainability is a very core concept when it comes to Akash Labdhi. Why is that? Because unlike other conventional structures out there in space, our structure is a soft structure. It does not create metallic fragments. It does not create high speed. Whenever metallic space debris hits ISS, so it creates a compound effect. Where it creates a chain reaction sort of effect, where multiple space fragments or metallic fragments start being generated, and these fragments are very very small, all the way from 2 millimeter to a 5 centimeter, and these move at a speed of around 7 kilometer per second, which is approximately, if you see, 17,000 miles per hour. So the
Right.
advantage with soft structures or inflatable structures is we do not have exterior metallic components. So any space debris that hits us, it only creates polymer or fabric based fragments, which pose no harm to any other space asset. So
Okay.
that's a very big advantage when it comes to sustainability, when it comes to inflatable space structures, in
Mm,
fact.
exactly. So, when do you realistically see space habitation becoming economically viable, and why is inflatable habitation the future of human space flight?
Right, ma'am. So I'll start with the second question first, and because that links to the first part of the question. Inflatables, very fun, very in very simple term, it's like a balloon in space. A balloon that is radiation shielded, a balloon that is space debris shielded, a balloon that has all the capabilities for humans to work, stay, and work in space. Now, since this is inflatable, your launch weight is 700 times less than the conventional structures. So, if I have to create, I'll give you the example of our first launch, in fact. So, this 70 cubic meter space structure that we are sending in our first launch, The same structure when it comes to conventional would weigh anywhere around 80 to 90 tons. Whereas the
Okay.
same thing when it comes to inflatables just weighs around 130 kg. So
Okay.
the difference in weight is too huge. And what this difference in weight does is it transcends to the cost part uh, of launching. So where you have to spend around maybe 70 to 80 CR to launch a conventional 70 cubic meter structure, you only have to spend around 2 to 3 CR to launch an inflatable structure of the same size. And what
Okay.
this value addition does is that allows us to reduce our infra cost when we go to the customers. Suppose we have academia in India who wants to do microgravity research. There's a lot of talent in India for microgravity research, but finding that infra in space and at that nominal cost that academia then that can afford is very difficult, but that is possible with inflatable space structures. Now the second part, when it comes to sovereign autonomy, now the world wants to have their own space heritage. Every country is moving to have their own space station, their own space existence, but every country does not have the capital and the resources that the West has to create their own ISS. With inflatable space structures, that is very much possible. So instead of you spending around 160 to 170 billion dollars to build a structure and put it out there in the orbit, you have to spend only maybe 50 to 70 million US dollars, which is just the price of a Su-30 aircraft, to create your own existence in space via inflatables. And this is a huge advantage when it comes to geopolitical or national sovereignty in space. You don't, unlike ISS where you have five, six partners, there is a lot of conflict among these partners, the P5+1 nations. And because of them, a lot of third world countries get left out. Whereas most of the talent comes from third world countries. Most of the engineering comes from third world countries. So with inflatables, it is possible for each of these countries to have their own existence in space. And
Right.
that is what ensures that inflatables are going to be the future of space, not only in orbit. Orbit is just the phase one that we are targeting. When you see
Mm.
lunar settlements, when you see Martian settlements, the precursor structures have to be inflatable. It cannot be
Mm.
a hard structure, because
Right.
when it is, imagine you're spending 12,000 US dollars per kg just to send to the low Earth orbit, which is 300 to 500 kilometer from us. Imagine going to the moon, which is 1700 kilometers or 1800 kilometers. Imagine going to Mars, which is 3500 kilometers. So, and with the space economy moving towards privatization very fast, uh, government's role is slowly getting miniaturized. A big example of this will be SpaceX, which has undertaken an entire ecosystem for NASA. And NASA has stopped doing the launches. It is SpaceX who's doing the launches now for NASA. So you need lightweight, compact structures that expand into bigger volumes when they are in their final destination. That can only be provided by inflatable space structures, because they have scalability, they have modularity, lightweight, cost efficient, which all these four parameters matter when it comes for a business or a startup in space to become profitable. And this also matters for other businesses who want to operate out of space. You want to do drug development in space. So currently what's happening, you develop 100 vials or 50 vials, bring it back to Earth. That that doesn't solve anyone's problem. It's not like only 50 or 100 people have cancer on Earth. There are billions
Mm.
and billions of people who are suffering with cancer. So you need to create trillions and trillions of drug vials. How do you do that? Where is the infra to do that? The only possible infra to do
Exactly.
that is the inflatable space structure.
Okay. So my next question is, what were the biggest technical and strategic challenges in bringing this concept to launch readiness?
Ma'am, I'll start with the technical challenges. The biggest technical challenge, as I told you, we faced with the materials part. The structure part, we had already solved when we were at IIT Roorkee. When we
Mm.
were doing our, masters and PhD there, we already had solved the structure part. But when it comes to the material part, that was something, because I am a mechanical engineer by background. So I don't have that material edge. So solving that material part was a big challenge, where we got help from Professor S.S. Banerjee from IIT Delhi, who's also an advisor in our board now. Our entire material teams now comes from IIT Delhi, Department of Material Science. So we knew that the material had to be solved first. We solved the material. Now came the second technical challenge: how to test it and validate it. Now, everyone cannot get access to ISRO facilities, and that is
Right.
where uh, organizations like IDEX, which we are a winner of an IDEX challenge as well from Indian Air Force, where these guys came in. And now we had the doors open from DRDO. We had doors open from the Terminal Ballistics Laboratory, which is in Chandigarh. So all defense labs door opened for us. Then
Mm.
again, we got incubated in IISc. So now we had IISc's infra to us to test that. So it was so this was something like that when it comes to testing and validating, it was a technical plus strategic challenge.
Mm.
So and we
Okay.
the way we solved this challenge is we ensured we had good relationships with academia. We ensured we had good relationships with the defense labs, and we tried to balance both of these and get our systems materials tested. The second biggest challenge now came was till now India expertises in satellite technology. I mean, I would like to say we are the best in the world when it comes to satellite technology. Now, integrating things in a satellite is very different. Integrating things in a soft or inflatable module is a different skill set altogether.
Yeah.
How so? We had to train our engineers, we had to train our team, find out frugal and novel ways to integrate the same avionics that go into a satellite into an inflatable soft structure. So
Mm.
that required a lot of innovations when it comes to attachments, mountings, and we first solved the attachment mounting problem. We innovated a very novel way of attaching the avionics into our module, and we have also filed a patent now for those attachments and mountings for inflatables. So this is how we solved. Strategically, getting to launch readiness was mostly about reaching a level of technology which was space qualified. So once we solved the technology part, the launch or the strategic part automatically started getting easier for us to navigate. And we had in space with us, we had the expertise of ISRO with us to
Yeah.
help us navigate through the strategic challenges.
Mm.
So yeah, that's how we did it.
Okay, so how does Akashalabdhi's modular and single launch scalable design reduce cost and improve mission flexibility compared to traditional space stations?
Yes, ma'am. So the first part would be the launch cost because we have lower, I mean, almost 700 times less weight, and we can pack the module into conventional fairings. So we are not
Mm.
dependent on larger rockets to send our structures to space. We are very, very launch independent. In fact, we are, be it a PSLV, be it a GSLV, be it LVM-3, be it a Starship, Falcon 9, or any sort of even small size, small payload rockets. We uh, we use a lot of origami and kirigami techniques to ensure our foldings are make our entire structure very, very compact. To give you an example, our 70 cubic meter module just fits into a 30 centimeter cross 30 centimeter cross 30 centimeter cube, which is the size of a 12U satellite. And
Right.
it can go into any fairing, any launch vehicle, in
Mhm.
fact. So that's one part. Second part is you do not with conventional structures there is a problem that you have to do multiple launches in space to assemble them. So with inflatables it's a single launch deployability. You launch the entire structure into the orbit or to the surface, it inflates, and you have a ready structure to move in and start carrying out your operations in space operations.
Okay.
The third part again is for conventional structures or conventional space stations, you require a lot of spacewalks to manage them, maintain them, maybe also assemble them. But again, the thing is, how do you send a human out there first before having a structure out there? And that is
Mm.
a very, very costly affair. You can't have the human floating around in the orbit and then
Exactly.
sending the structure and start doing it. So with
Mm.
inflatables, you don't have to do those expensive spacewalks or those life-threatening spacewalks out there because now space debris is a big challenge. Imagine your astronaut is going out and doing a spacewalk to assemble or repair the structure, and suddenly you have a 7 kilometer per second particle coming and hitting at you. So
Mm.
that's life threatening. With inflatables, you avoid that. That's another cost efficient part. And the most important cost efficient part is you get a very disproportionate operable volume in space with inflatables when compared to traditional structures. You know,
Mm.
Imagine an entire ISS where it's only sufficient for carrying out some experiments and
Mm.
some value addition work. But imagine inflatable of the similar weight class, giving you a space to have 30 to 35 humans working on different projects simultaneously. So that multi-use capability comes with inflatables. And second, the re-entry becomes easy. the life cycle of the structure is more than a conventional structures, because again, the impact of space debris is less, the impact of atomic oxygen effects are less, the impact of UV degradation of materials is less, because again, those things have already been solved, and that's how it has reached that stage. Uh, and once the life cycle is done, it is very easy to reuse the space inflatable habitat as well. So you just have
Okay.
to deflate it, bring it back to Earth, carry out the maintenance, and send it back. Or else
Mm.
you can also carry out the maintenance in space as well. You just have to replace the material layers, which is even
Okay.
easier. So both of
Mhm.
these capabilities gives the versatility edge to inflatables when it comes to conventional structures.
Mhm. So, if I talk about international collaboration, like with ESA and European partners, so that play in advancing Akashalabdhi's technology and global credibility. So, can you elaborate more about this?
Ma'am, so when anything when we talk about space, it is a human affair. It is we have to think less from a nationalistic angle and more from the humanity angle. In fact, a good short example would be when humans started exploring the oceans. It was more of a combined effort that made it possible. Of course, later on, it became a very geopolitical or geographic constrained affair. Similar thing is happening with space. Initially, it has to be a combined affair of
Mhm.
effort. We have expertise in some technologies. ESA has expertise in some other technologies, and it has to be a combination of both. For example, ESA human space flight missions are earlier. So, as a startup, as a company, our time to reach to the market has to be very, very fast. We cannot wait for 10, 15 years for the market to evolve in the Asian region and then jump on it. I mean, our survival is also on the line. If we survive to fight is only when we can make our vision come true. So with the global partnerships happening with the West, it gives us an edge when it comes to reaching the market fast, gives us an edge to validate our technology, validate our commercial proposal, and also it provides the other partner also. So like for example, ESA. It provides ESA also a good opportunity to explore the new innovations that are happening in human spaceflight. So they get a very good place or they get a very good infra in orbit to carry out their advanced human flight operations, which are already on the pipeline. So it's a win-win situation for both the parties.
So, do you see Akashalabdhi integrating into global programs like Lunar Gateway or future Asian space initiatives?
We are pushing it, ma'am. I mean, from our side, we are trying to talk to all the stakeholders involved with Lunar Gateway, the Asian projects that are happening for human space flight. In fact, the Martian projects happening as well. So we Habitat is just one part of our verticals. We have our inflatable solar arrays that can provide gigawatt level of power for data centers. We have our inflatable rovers, which can carry out much efficient Mars and lunar exploration. So with these verticals, we are trying to enter these programs as well. But again, we can only try the best from our side, and it depends on the other party if they want to adopt our technology and our product. So,
Right. So, what milestone will define success for Akashalabdhi over next 5 years, if I say, both technologically and commercially?
ma'am, our first
Okay.
launch where we are pushing our 70 cubic meter habitat with six payloads of multiple use cases, not only validates our technology, but also validates our commercial use cases. And since we will also be doing a re-entry of all these payloads and all this structure back to Earth. So that validates our entire ecosystem approach of doing things in space. So this first launch is going to be a key milestone for Akash Labdhi that defines our next 5 years of existence and 10 years of vision.
Okay, that's wonderful. And in the last one, I want to know where do you think Akashalabdhi could add the most value in future space exploration systems like autonomous rovers or self-sustaining habitats?
Ma'am, both of these cases, I think Akash Labdhi is very much capable to add a lot of addition. But our
Mhm.
core vision relies on making humanity a multiplanetary species. So, for example, a lot of problems on Earth where we are facing a deficiency of a lot of minerals, deficiency of energy systems. Space is a ready solution for all these challenges that we face on Earth. And
Okay.
if humanity becomes a multiplanetary species, Earth can become a sanctuary uh, where most of these heavy industries will then move out from Earth and start operating from a lunar surface, a Martian surface, or from orbit. And that makes life for other humans on Earth much more easier, much more habitable. This The issues with air pollution, the issues with water degradation, the issues with landfill pollution can be totally eliminated once we start thriving as a multiplanetary species. And from that angle, I think human habitation and uh, exploration using autonomous rovers both have to go side by side to make that happen.
Right, right. Thank you so much. And with AntarikshHAB, India steps confidently into the era of sustained space habitation, a bold vision that places the nation at the forefront of the global space economy. Thank you, Siddhaji, for this wonderful conversation. Thank you once again.
Thank you so much, ma'am.